So when starting analog electronics, it can be a little bit daunting at first. There's a lot of different components and a lot of different pieces to put together, and it's easy to get hung up on the end result and really just think about that. When you look at really complicated synthesizers, they sort of appear to us like magic little boxes that make sounds. And for a long time that's how I thought about synthesizers. I vaguely knew about the different components inside of them, or that there were components working, but I didn't understand how those components worked together, or what those components even were at all. So the main purpose of this, video series is to really get into the depths of analog electronics in regards to audio production, like making sounds with electronics. And that's pretty much all synthesis is making sound with electronics. And it's really no different than just a different kind of musical instrument that instead of having air pumped through it or being struck by a hammer, simply electricity or current is moving through these circuits that we build, which then tell a speaker cone how to vibrate. And it's basically just another form of musical instrument. It's really no different than any instrument we play, except that what is happening is much smaller and much faster. So it falls a little bit beyond what we find intuitive, or like perceptively intuitive. And I think that's where a lot of the mystery around analog electronics can come in. And so, yeah, kind of the main focus of what we're going to work on together is just really getting into what these components are and how to use them and how to get you set up making electronic things as quickly as possible without too much confusion. So, see you next time. So today we're going to start with just a very basic circuit. This is a circuit that I originally saw on Look Mum No Computer as a kind of, it's a YouTube channel that goes through analog electronics, mainly for synthesis purposes, and I saw it and I thought, okay, that looks simple enough to do, and it'd be a really cool way to just kind of start making an oscillator, or at least just getting some sound out of electronics, doing a little deeper research on how that video is set up, or kind of the circuit that it teaches. It might not be the best oscillator in the entire world, but I think in terms of just making electronic sound with just a few components, and kind of a cool little physics trick, which is kind of, I guess it's kind of like negative resistance, or it's called a reverse avalanche setting for a transistor, which we'll talk a little bit more about that later on. But just for now, I thought it was kind of fun to make, so we're just going to make it. So if you look here, I have really, just some breadboard to start with, and just as a little reminder for all of you out there, you have up here the power rails. This is what's going to send all the power to your breadboard. So as long as these are plugged into your battery, which, by the way, for this circuit, you need at least 12 volts. So what you have to do is take two 9-volt batteries and then you plug them together. I can kind of show you how that, well, you can kind of see it here. You plug them together like that, and then you just kind of hook some wires around the positive and negative terminals, and then this is what's going to plug into your breadboard and light it up, so that, yeah, you can have some power. If you don't have at least 12 volts in it, I don't think the oscillator won't work. So you got to do that, or if you have a power supply that you can change how many volts are going into the breadboard, that also works. But yeah, this is a very just a quick way to get past that. And so yeah, I'll try to explain every single component that's going into this circuit, just for anyone that doesn't know electronics really well. But just to say that I am not an electronics expert. I'm not an electrical engineer by any means, so I'm going to give you the best understanding that I have of it, and hopefully that helps you maybe figure out what these things are actually doing on your own a little bit better. So just to review, we have our breadboard, and power is going to go into here, and then when we have our power set up, we have to send power into these vertical rails. And just so you know, that little alley down the center of the breadboard, the power doesn't go across that. The power only goes on the side, like one of these sides, if it's plugged into a power rail. And the reason for that is, well, not to get too off topic, but is mainly because there's these things called integrated chips, where you have little terminals in like the same row, and you don't want the power to go from, you know, kind of like, yeah, maybe I'll show it up here. You don't want the power to all be on the same row. So you go across that little alleyway, and that gives you the ability to send specific signals to specific pins without overlapping. So that's why the breadboard has that little gap in the middle. But we're not going to worry about that today. We're not going to use an integrated chip. And that's really a big reason why I liked this circuit to start off with, just because you don't use any integrated chip. And that means that everything you're doing is just really basic components, and it gives you a chance just to think about, you know, how current is flowing through components and making a speaker cone vibrate or oscillate. And for me, I think that's kind of interesting to get pretty low level in terms of our circuit building. So might as well get started. So for this, well, let's reverse it this way. I know there's probably maybe more of a breadboard etiquette in terms of the direction, power supply, so excuse me, electrical engineers, but I'll do my best. So for this, I have a setup. You're gonna probably want your positive rail kind of a little bit closer to you. This isn't, you know, universal in the way you do it every time. The way you set up your breadboard is actually pretty creative and expressive. It's kind of up to you to figure out. I'm sure, like I said, electrical engineers might not agree with that. I think there is kind of an etiquette to the kind of the flow of your breadboard and the colored wire that you use, but I'm just a composer, so I'm just going to have fun with it. So yeah, I think also what's kind of nice is that once you understand the flow of the breadboard, you can be much more creative about how you set it up and then coming up with creative configurations. So just to show you before anything is happening, you know, this red wire is the positive terminal coming out of the battery, and this yellow wire is going to be going into our negative terminal. So if you look closely, you can see on the camera, so this red wire is on the red rail, and this yellow wire, which I used because I think I didn't have a black one at that moment in time, is going on the blue negative rail. And for those out there who may not have too much electronics experience, that's okay. Basically, the whole idea of a circuit means circle, right? Or something, circumference, that kind of word, circle. It means something is just a big circle, right? And all we're doing is we're letting positive current come in to our breadboard, then it's going to go through our little oscillator, do some stuff, and then it's going to pop out on the other side to ground, and then there's going to be another out which is going to be going to our speaker, making an oscillator. Okay, so we get that. That's not too tricky. So there's kind of two ways to go about wiring your breadboard. You may have seen stuff like this before. These are called jumper cables. They're pretty, they come in all different sizes. A lot of times the sizes don't totally line up with what you're trying to do. And so in that case, I recommend getting yourself a pair of these. I'll do it over here. Yeah, so very basic. This was super cheap. It was like $7. You have your basic, cut the wire, and then you have what's called a, I'm blanking on the name. It's like a wire stripper, but basically, you can take any wire and you can cut it, and then you'll have a little nub, but there's no wire coming out, and so then you just take it over here and kind of get it through there, and then the wire will be exposed. It's hard to see. See if I can, yeah. Anyways, you get the idea. It's just a way to kind of change the size of the wires you're working with. What I think is actually a little bit cooler than jumper wire though, is just using straight up like a wire dispenser thing. Like all these are just on like coils of wire, and you just pull them out and cut them to any size you want. So it's a little bit more fun in terms, and they're a little bit sturdier feeling, I would say. So yeah, we can just hop in. So leave a little space for your battery to get plugged in over here at the top. We're gonna plug in basically some power going from, let me get this on. Okay, yeah, we're gonna plug in our power supply into a first little row of things. So I'm gonna strip off just a little bit more of the rubber so I can really get, oops, I accidentally cut it, okay. I think it needs to be smaller anyways. Okay, so yeah, I've just stripped off some of the rubber, you can see that. And I'm just gonna go from over here to over here. So now that I plug this in, and you can make this even smaller if you wanted, so it doesn't have the little loop in it, but we'll just go with it, why not? Yeah, so so now that this will be plugged into our power rail, that means that just this row, these 5 little pins, I think they're called, I don't know, these 5 little things will have power. And nothing else on the breadboard will have power. So now we can plug in kind of our next thing in the circuit is just going to be some resistors. Now, if you're not familiar with electronics too much, a resistor is a really kind of basic electrical component. And really all it's going to do is take current that's coming a little bit too fast and say slow down, right? Because the components that we're using can only take so much current so quickly. And if it gets too fast, you run the risk of burning out something or something getting too hot. Maybe, I don't know, just basically it slows it down. And so the first resistor we're going to use is this little blue one. And it needs to be 1,000 ohms. So if you look on the little package here, it says 1K ohm with 1% tolerance. So basically what this means is that provides 1,000 ohms of resistance, which isn't a ton. It's just enough to keep things from getting a little bit too fast. And later on you'll see that this is actually what is going to protect our LED light, our little light emitting diode, or LED, from burning out. If this wasn't in the circuit, too much current would go into the LED and it would be able to get so bright that it actually just burns out. Which is kind of maybe one of the pitfalls working with analog electronics versus digital electronics, right? Digital electronics, everything is going to be just, in the computer crunching numbers. Nothing physical is going to really happen. But analog electronics, you're dealing with actual energy going through components. So, it can actually have some physical damage can occur. So, we're not dealing with too much power here, and so there shouldn't be too much concern about, burning anything. So, but still always be cautious with the stuff you're using. So if you look closely at this resistor, see if it'll zoom in. Maybe not. Maybe up here. Will you look? See it? No, it's too much. Okay, so it's a little hard to get on the camera, but if you look closely at resistors, they have all these little stripes on them, and those stripes correspond to resistance values. And every single box of resistors comes with this little chart over here that says, what color is associated with what amount of resistance and the amount of tolerance. And by looking at the colors, you can add together how much resistance there is, even if you don't know. I will say, for me, I haven't figured out how to read a resistor and tell you how much it is, so I recommend not mixing up your packaging. Otherwise it might get a little confusing, but if you can afford it, I do recommend getting a tool like this, which is basically a very basic multimeter that is really, really useful. Because even if you don't know what anything is, like the current or resistance or whatever, all you do is grab your multimeter, and what it's going to do is send some current through that resistor, and it's going to give us a little reading in terms of how much that is. So you can see it here in the camera up there. There it is. So if I just touch this resistor with these two little electrical things, let's see what it says, if I can get it to work. If I can hold it steady and actually get it to touch, look, it shows 1,000 ohms. And it's fluctuating, right? It's not totally 1,000 ohms all the time, but it's really close. Like, yeah, we're looking at like 1,000 point, it's really close. And so if you notice, it does fluctuate. And that's because, we're dealing with actual current. And it's not perfect. It comes, faster and slower at different points. And so that's what the tolerance refers to. And this one has a very low tolerance. I guess, it doesn't fluctuate very much. So it only fluctuates up and down by 1% is basically what the tolerance is for this one, which is pretty solid, right? And that's pretty much what we saw on the meter, so that checks out. Now, getting into what a resistor actually is actually kind of amazing. Kind of the tendency with electrical things, at least for me, because I don't have a degree in electrical engineering, was kind of that there are all these magical little pieces of stuff that you put together and, you know, build things like synthesizers, you know, computers, printers, I don't know, whatever. And it was a little bit above my understanding. But taking some time and researching, like, I don't know, what do every single one of these components, what are they actually made of? How do they work? Has been really helpful. And I would say that that was the point that I started to feel way more confident about putting stuff into the breadboard. Before that, I was a little bit like, I don't know what I'm doing. And I felt like I was just kind of following YouTube videos and hoping that I can just follow as closely as possible without messing up. And you know, sometimes it works, sometimes it doesn't. But I feel like it's much better if you can just learn what all these components are doing, as opposed to trying to just copy someone else, which that's what I had to start with because I didn't know what they were. But once I started figuring out what they were, well, I was at least able to copy a lot better. So anyways, so I'll try to spare you some time and tell you a little bit about what a resistor does. So a resistor isn't all metal, actually. So this is, I think this is a polarized, or it's not polarized, which means both ends, you can basically have current going one way or the other. It doesn't matter what direction it's in. If it's a polarized transistor, then there's going to be, I think it's anode and cathode, or like a positive and negative terminal. But this isn't. This can go any way. So don't worry about the direction on this one. But what you have inside of that little blue casing is actually, the casing is made of resin, and inside of that is a wire going through a ceramic core. And that ceramic core has actually, they grind a spiral into the ceramic core. And the more loops that are in the spiral, the longer it takes the current to travel, because there's more stuff kind of, you know, there's less connectivity in there. And so it moves slower through it, which, I don't know, to me is kind of amazing to think about. Like, inside of this is a little piece of ceramic core, and really to change the amount of resistance in a resistor is a very physical thing, you know. It's just carving different amounts of spirals and ceramic cores. And I can maybe post a link to some of the sources I watched to figure out how that looks like on the inside, in more detail and better physics talk. But for me, I think that's really cool. So now, basically what we're going to do is connect our 1,000 ohm resistor. And it's going to go into that same row that we just plugged in our... So we're going to plug it into the same row that we started with, or that we just put power to. And you'll notice, okay, hey, that's a little bit big and up there. You don't have to leave them that large, you can, but I think since I kind of have a vision as to what is going on here, I'm just going to snip off some of this extra wire. I don't know if there's any way to like recycle wire or reuse it or do something. I don't know if you can use it for like soldering, but anyways, yeah. So, you know, before you put it in, kind of set it up in the dimensions that you want, and then just pop it in. That's it. Okay. So now we just added a resistor to our circuit, which all that's going to do is just make sure that current isn't going to move too fast and fry our LED. So let's give it another go. Let's keep going. So the next component we're going to add is called a potentiometer. And what the only thing a potentiometer is actually another form of resistor. Sometimes it gets the nickname a pot, maybe short for like potentiometer, pot. But just in case some of your like more well-versed electronic friends say like, oh, I put a few pots on it. You know what that means. That's kind of the lingo. But basically, all it's doing is a variable resistor. And so, you know, how does a variable resistor work? Well, let's talk about it for a second. So if you notice, there's 3 little legs on it. Basically you have current going in, current going out, and then, kind of blanking on the middle one. But basically what you have is a little piece of resistant metal, maybe it's like tungsten or something if I recall, that current is going in, and when you turn the knob, there's a little connector on that tungsten, or whatever the metal is, I forget. And it's going all the way around, and you know, if you have the tungsten all the way, you know, down, then it can make the connection immediately. So it's the lowest form of resistance. But if I turn it all the way to the other side, then the current has to travel through that tungsten or that material all the way from that side to that other side that is getting a lot more resistance. And so basically when I turn the knob, I'm changing where on that material it's connecting. And that's how a potentiometer really gives us, you know, the ability to change the resistance, which, you know, in terms of inventing this stuff from nothing, I feel like that's a pretty profound thing to figure out. When, you know, early electronics were being developed, it was like, well, we want to be able to vary resistance, right? Because we can't have everything just be fixed all the time. And just this idea of having kind of this horseshoe that then a connection can move around on to change how much of the resistance is there. Pretty profound little device. Something I think we take for granted, especially if we play with like MIDI controllers and stuff that, you know, are covered in potentiometers. You need to realize that this is what is actually doing the work when we're changing all the parameters, and it's getting transformed into digital information, but still, at the end of the day, it needs to be, you know, electronics are still involved. So take some time and think and appreciate your potentiometers. So that goes there. Before I plug it in though, there's a little tricky thing to get, and for it I'm actually going to use a jumper. It's hard to get out. I just need to, oh there's one. Okay, here we go. Yeah, so basically you just need to jump from, so where that resistor is now going to another row, that row now has power, which then we need to plug in, oh actually I need one slightly bigger than this, because the potentiometer goes across, if you look closely, it goes across 5 pins, like each pin has a row in the middle. So we need the blue one that's just ever so slightly larger, but it's designed to basically just go across, just jump a row. So I have my blue little jumper cable, or little jumper, oops, over here. See, it's super tiny, very cute. I'm gonna pop it in there. And so you gotta focus a little bit, make sure you get the right row, but yeah, okay. So all that's gonna do is make sure the middle leg is also getting current. Oh yeah, now that reminds me. So what's coming out of the center leg is really what the current is connecting to, and then the other leg, or the other terminal, is actually doing the same kind of potentiometer thing, but the opposite direction. And this is where things maybe get a little bit above my head in terms of like electrical theory, how it works, but I'll post a link to something that explains it a bit more in depth. So there. Now we plug in our potentiometer. That leg, if it's facing towards you, the left leg should now be in that row that is with the resistor, if you can see that. I'll try to show it over here too. So if you look, the leftmost leg of the potentiometer is in line with that resistor that is coming from that row we supplied power with. Oh, and I looked more closely and I just realized my power supply isn't going to the resistor. So I'm just going to pop it over a row. That's the nice thing about breadboards, is that if you make a little mistake like that because you're learning, it's not the end of the world. So there. So now we have our power supply going to a resistor, 1,000 ohm resistor, potentiometer, and don't forget to connect. Basically, we've connected, if you can see that little blue jumper in there. Little focus. Yeah, that little blue jumper under the potentiometer, that's connecting the middle leg to the left leg. So yeah, don't forget that. Okay, great. So now we can start to get into more of the heart of the circuit. So let's grab a few more components. So what we're going to need next is going to be a 10 nanofarad capacitor. And then we're also going to need, what is this in here? Here we go. So you're going to need a 10 nanofarad capacitor. You're going to need a light emitting diode, also known as an LED. The little things you have in the TV, but they're super tiny there. This is a pretty big one, I guess. So you're going to need the LED. And then you're going to need really the 2N3904 transistor. So I'll try to show it up here. It's very tiny and hard to see. I don't think it'll focus. Maybe? Okay, maybe not. But what you have are 3 little legs, kind of like a potentiometer, but a little bit different. So basically a transistor, often it'll be called probably the most important thing ever invented in electronics. Definitely it has been the thing that has probably revolutionized the modern world. And basically the only thing it is a switch. And you have current that goes in and out the other leg, and a middle leg that receives current, and when it receives a certain amount of current, it closes the switch, and when it receives enough current, it opens the switch. So it just is the ability to start and stop current, which doesn't sound too impressive by itself, but when you think of maybe the binary language of computers, right? 1s and 0s, or really any language that often is very binary driven, you're able to describe a lot of stuff, and you're able to create what's called logic gates, which is a little bit more fancy in terms of like computer thinking, but you're able to do a lot of stuff with just this little transistor. It's really what most electronics really depend on to work. So the way it works is a little bit mysterious. I'm not gonna lie. From what I recall, basically there is like is that the capacitor? Is this the one that has the... Yeah, so basically, it's a little bit mysterious how it works. There's two kinds of substances inside of it that... Okay, I'm not even going to try to explain this. This isn't going to go well. So I'm going to review that later. But, yeah. So, kind of the weird thing about this circuit, and yeah, it's kind of weird. You're going to take your transistor, and you're actually going to cut off the center leg. I know we just talked up all this stuff it can do, and now we're just going to basically chop off the center one. And the reason for that is what's going to really let this oscillation happen. And you really have to cut a little bit closely to the thing. Otherwise it won't work. So you just got to get in there and cut it off. So now you have this transistor with two little legs. And I don't know, so sad. So yeah, let's see. So now you want to plug the transistor into where the right leg of the potentiometer is. And then a few rows down, have some stuff over there. Okay. So just pop that in there. So now we're going to take our light emitting diode, or LED, and we're going to plug it in. Now you have to remember, a LED is a diode. And what a diode does is allow current to only flow in one direction. And so that means there's a positive end and a negative end. A cathode and an anode, I think. And so the longer leg is going to be the positive end. So kind of separate them a little bit, add a little bending to it is kind of an easy way to get it. And then connect it to basically the row that your transistor is now touching that's not on the same side as the potentiometer. So touch it there, and now what we're going to do is take the capacitor that we have, which also has a positive and negative end, and we're going to plug the positive end into where the LED is. So just on that same row, and then the negative end is going to go back to where the transistor is by the potentiometer. So now I'm just going to plug that in to there and there. Yeah, okay, it looks nice. So capacitors are very interesting as well. And they're also a super important electrical component. Basically all they do is store a charge for a little bit. They add a little cushion to our circuit. And that's really what's going to help the oscillation happen, because basically current's going to go into the capacitor for a second and then hop out, then go out the capacitor. And the way it works is a little bit complex. It has to do basically with kind of the substance in the middle that, electrons can't go past. And so all the positive ones get stuck on one side, and then when the current changes direction, they all rush out and run to the other side. And then same thing, they go back. And so this, I guess, will happen pretty quick in this circuit. Okay, so we're almost there. There's a few final touches we have to do. So now we have to add a, let's see, where is it? Okay. We have to add a 100 kilo ohm resistor. So it'll look a little bit different, but yeah, we have to add a 100 kilo ohm resistor, and this is actually going to hop across that little center alley. I'm going to snip off some of the access wire. We don't need it. And I'm going to plug it in to the rightmost leg of the potentiometer where it lines up with the transistor and the capacitor. That's going to go right into there, and it's going to hop across the alley. Actually, don't forget to bend the legs before you plug it in. So this is going to jump across the alley onto the other side of the breadboard, which, because we have power in this circuit, that means this row on the other side of the breadboard now has power. So don't worry about not having power. And what's exciting is that this row on the breadboard is going to be our audio signal. That's what is actually going to be, the sound is going to be coming out of there. Now there's one other connection we have to make, and it's a very important connection. And that is going to be our ground. So I've just snipped a little fresh wire. I'm going to try to do a rough measurement. So we're going from here to there. Probably be a bit smaller, but not too small. There we go. And then we just strip some of the insulation off. It's a bit of a crimper. That's what it's called, crimper. Oh yeah, you do the crimp. It's kind of like, I think it's used in bouldering as well, when you have a really tiny boulder. Crimp. Okay. Okay, there we go. So now I've crimped the wire, and this is going to be our ground. This is very important because everything in the circuit that's going around is going to find its rest at the ground, right? So that's going to connect to our LED and capacitor section over here, and that's going to go all the way over to the blue side. I'm going to make these wires just a pinch more exposed because I want to make sure the connection is good. And then I have to charge the camera. Okay, go. We can crimp it a little bit better. Not that much. Okay, I think that should be okay. Okay, so we plug that in there, and this is going to plug over to our ground. Okay, cool. There. Alright, so now let me have all that going. So now we need, let's see here. Okay. Okay, so the next thing we need to put in is our audio out. And so I had to take a little time to figure out how to do this, but basically what you need to order is little 1/8 inch jacks. And now when you get them, they're going to have 5 pins on them. Like 2, 1 in the middle, and another 2. And you might say, well, which one is which? One way you can go about that is grabbing your multimeter and figuring out what is actually taking what, voltage and stuff. So that's one way to check. You can figure out what's the ground as well. But I'll just tell you because we figured it out. So basically, the way it works is that the center pin is the ground, and the outer 2 pins are the right and left channels. I'm not sure what the 2 pins in the middle do, to be honest, but I do know those. And the way these actually work in terms of having a lot of different things happen with just a single plug is pretty amazing, I think, in terms of, I guess, just an invention or kind of engineering perspective. Not to say I'm one to judge, but yeah, it's pretty cool. Which, for me, I've always thought 1/8 inch things, you just plug it in and it makes audio sound. But there's actually a lot going on in here. But this is what's going to give us our signal. So, let's see. Can I actually do that work? No, it doesn't. Let's not do it. Okay. So I'm just going to plug it in over here, and let's see. Actually, it might be better to just do it over here. Give this a try. Okay. So what you need to do is run a ground. So we're gonna, for me, I'm using black cable as a ground. It's about the same size as the other one we cut. So chop it, crimp it. Crimp. Okay. And so decide which one you're going to put stuff on. I'll do it. I'll do it over here. Okay. I think it should be okay. So this middle, you can see over here, I'm going to put the ground in the third little row, because when I plug in this thing, that's where the ground lines up, so I'm going to put that over here. It's going to go to ground. Like that. Okay? So that's good. So now I can just plug it in. It's going to ground. And what's nice about using this is that you can plug right out of your breadboard into an audio speaker. And the thing is that you have to, basically like a monitor can work, but it has to be powered. Because this is actually just a passive circuit. There's no op amps in it that will increase the output. So it's not going to put out very much power, it's just going through it. So you need an amplifier to do it. And that's really what a speaker is, right? It's a big amplifier that takes the signal happening here and lets us be able to listen to it. Okay. So now we need like maybe one more connection, but we'll go for two. Why not? So I'm just gonna grab maybe like, I don't know, maybe some yellow cable over here. I'm gonna cut it in little pieces because it has to go from this side over there. So actually it's a little bit too long. So about that long. You can see I'm gonna crimp. Yeah, I think crimping is kind of fun. I like it. Crimp. A little bit more. Okay, crimp. And that's going to go from the one side of the, or the furthest most pin of the 1/8 inch jack to the little row on the other side of the breadboard that has our resistor. And that's where our audio signal is going to come from. So I'm going to add another cable, a little bit longer because it has further to go this time. And I'm going to connect it to the other channel on the 1/8 inch audio plug jack. This way you'll have stereo output on your breadboard. How great is that? Okay. Plug it in there, and then plug it into the exact same row over there. Okay, so there it is. This is this should be our, don't forget the potentiometer. Okay. So this should be our most basic oscillator, using, you know, just some basic components. It'll have some limitations, as we'll find out in a moment, but that's how you put it together, and hopefully some of the explanation of the components can help, I don't know, give you a sense of what's going on here a little bit more clearly, and help you get started building some of your own circuits. So yeah, take a moment and take a look. So cool, let's give it a listen. And we can hear it if I turn on my speaker. And it goes pretty, this one's pretty low. Yeah. So you can see it's actually still blinking, but it's blinking so fast we see it as a continuous. Pretty nice sound. Oh yeah. And if you notice, it actually has, so it tops out there, but the low end you can go, I mean, down to just like individual hertz, you know. If I go as low as I can go. Now I'm just getting clicks like tick a tick a tick a tick a tick, like quarter equals 100 or something. So what is that, like a C negative 2 or something? I don't know. And then I can just keep cranking it. Okay. And so that's pretty much it. I was having a little trouble getting it going just a minute ago, and what I realized is that the LED was actually in the wrong way. So I thought the positive end connected. I'll just turn this off so you can hear me. I thought the positive end connected to the leg of the transistor, but it actually is the opposite way. And I think that kind of makes sense because this whole circuit uses a little bit of weirdness called negative resistance, and the transistor is in reverse avalanche kind of mode, and so I guess, yeah, it's actually negative. Anyway, so you just swap the LED from what I said earlier. So awesome. Now what we're going to maybe explore next is adding another oscillator here so that this breadboard can become a little 2 oscillator synthesizer. So, see ya. Okay, so now we're going to do a little work on this circuit. So basically all I'm going to do now is build the exact same circuit, and it's just going to be over here, and so that way we'll have 2 oscillators to work with as opposed to just one. And what's kind of cool about that is that we get to build a very simple little mixer on the same breadboard so that those 2 audio signals can mix together and come out our 1/8 inch jack over here, which then plugs in to a monitor, a speaker that has an amplifier in it. Like I said last time, this is a passive circuit, so it's not going to work if nothing is amplifying it. So, you know, if you have like a little tiny breadboard speaker and you're trying to get sound to come out of it, it's not going to work because there's not enough oomph coming out of the breadboard. Okay, so basically, let's now build the exact same circuit, but kind of a lightning round. And I'll talk about it again a little bit, but for the most part, we're just going to build it again with a little bit more of a continuous flow in terms of how we're doing it. So hopefully it's a good review for you. You can follow along and just kind of enjoy what's going on. Maybe I'll keep it plugged in because it's so pretty, you know, that blue LED flashing. I'm here for it. Okay, let's get this. Okay, great. So, maybe I should put a little strobe warning, but yeah. Okay, so we have our, okay, so you're going to need to send another power supply. You can't take what's coming out of this oscillator and just go into another one. So we're going to crimp another power supply cable, and maybe we can just put it over here. Try to get as much as we can onto our breadboard. This can go here, it can go into there. Okay. Cool. Oh, popped out. Okay. So yeah, we're gonna send power supply, and if you can remember from last time, we're gonna grab a 1000 ohm resistor. Just going to snip some of this. Oop. Not too much. Okay, oop, oop. Yeah, maybe I did too much, but I'll make it work. Bend them and plug it in. Okay. Hold on, let's redo that. Oh, the lighting is good. Let's try that again. Plug it in. Bend it. Okay. So there's that. We're going to grab our little tiny blue jumper again, and that's going to plug from this rail that the resistor is connected to a rail that is 2 over, leaving a little space in the middle. Yeah, that's for our potentiometer. Sometimes they're a little tricky to get in there, so let's see if I can get this to snap in there nicely. Okay, I think that should be good. Maybe a little, looks a little hee-hee, but okay, great. Okay, so next, we're just going to grab another potentiometer. And I'm realizing that in the first video I didn't say the exact kind of potentiometer that is needed here, but it should be a 10 kilo ohm. So it'll have this little B10K on top. Because it's a resistor, right, there's a certain amount of resistance that it can have. And so you want to have basically that much. And we're going to grab another one of our transistors, the little 2N3904. If you remember, we got to snip the leg in the middle. Okay. And make sure you get as close as you can to the black part of the transistor, just because if it's not really snipped enough, it won't work. And when you put it in, I realized I could have said this the first time around, it'd be a little easier, a little bit less confusing. The flat part, if you can see how it's a little flat there, should be facing you on the breadboard. That way it's in the right direction, and that should go to the third leg. or the rightmost leg of the potentiometer in that row, and then should go a little bit ways out, not too far. Let's just make sure it gets in there. Yeah. Okay, so there. You can kind of see, it's the same thing we did before. So maybe you remember what comes next is another LED, which for fun, I'm going to pick a different color. I'm going to pick this, it looks yellow here, but when you plug it in, it looks a little bit more orange. Now, let's get this right this time. The negative side, which is the short leg, is actually going to go to our transistor. Yeah, trying to explain the physics behind all this, that might be a little tricky for me, but at least in terms of what the electrical components are doing, it more or less makes sense. So yeah, we're going to grab another 10 nanofarad capacitor. If you remember what that's doing, basically electrons run to the positive side, and then when the current changes direction, they run to the other side. And because it stores some charge, it actually delays how much of that charge is coming or dissipating after you turn it off. And this capacitor is really what, it allows us to make light bulbs that can dim, gradual fades in things. It's kind of like suspension. It adds a little cush to your circuit. So as things are changing, things can change smoothly as opposed to there being abrupt cutoffs, which can result, I believe, in a short circuit, right? You basically get a 0 and it has a glitch and doesn't work. Or whereas in digital stuff, it gets a glitch, it doesn't work, whatever. You reboot the program. In an analog circuit, you get a glitch like that, and, well, something might burn out. So the less glitches you can have, probably the better. So the same thing, we'll put the ground in here. So the ground is going from this little spot over here where the positive leg, capacitor and the LED, they're going together, and then they're on the same row, and that's going to pop over here to our ground. Which, by the way, I maybe should have also said this. Alright, I put the battery on the other side just because it was getting a little crowded over here, and I wanted to plug in the 1/8 inch audio jack on this side as opposed to trying to fit the battery in, so I just moved the battery to this side. So you can take a look at that. Yeah, there it is. And that just kind of shows you the symmetry of the breadboard. There's a lot of different ways to put stuff together. It's not totally linear in terms of how it's pieced together. Okay, next thing we need to add is going to be 100 ohm resistor that is going to be the audio out for our second oscillator, which, and so we're going to cut it, not too tiny, just cut off a little bit of the excess wire. You don't have to, but I feel like it just looks a little bit cleaner when, you don't have these kind of like, I don't know, if you've seen like paintings with dollies and like dolly paintings with giraffes in them, they have these like little tiny legs and the giraffes are floating up in the sky like a cloud. It always makes me think of that, but maybe that's a little bit too much to be thinking about. Okay, so then, it's just like last time, I'm going to hop across a little alley to the other side of the breadboard, which, at least for me, I'll try to zoom in here so you can see that a little bit better maybe. For me, using that alley is kind of like a little, I don't know, just to get a little bit sense of a in-out flow of things. See if it'll focus. maybe. Yeah, so I guess kind of the thinking is like all the output is kind of coming on this side, and then all the interface and stuff going on is on this side of the breadboard. That's not standard. There's, I don't know, I'm sure there is a standard, but at least for me learning this stuff, that is standard enough. And okay, so now we basically have the same audio circuit ready to go, but we want to mix these two audio signals together. And so you might ask yourself, well, how do you mix together audio signals? I asked myself the same question. Thankfully the internet is rich with resources on how to do that. But basically, super simple. Well, actually, maybe before we mix it, we should test that our audio signal for this oscillator is working at all. So let's just see here. Come to think of it, we're plugged in. So the oh, sorry. My potentiometer is really plugged into the wrong place. Okay, and we're back. So I was having a little trouble with the second oscillator, getting it to work, and I was, troubleshooting, swapping things around, trying different components, seeing what happened, and it turns out that this LED just doesn't work. I don't know what happened to it, but these things are, I guess, delicate, and so it's going in the burner pile. But anyways, I found this. So I have this LED. It works. Nice green color, and it's flashing. So we know something's happening. So that's great. As a quick test, maybe we should just go for it and see if we can mix this stuff together. So we're going to make a super basic mixer on our breadboard. And the way we're going to do that is first we're going to start with, let's just zoom in here, just a titch. Scooch over there. Yeah, there we go. Okay, so first we're going to start with just moving these yellow cables over, let's just move them over to a rail over here, like that, another rail, I think they actually have to be on separate rails. And so that's going to give us 2 audio channels out on the breadboard. And I can kind of remember how I did this last time. Now we're going to take two 200 ohm, let's get in front of the camera. We're going to take 200 ohm resistors and pop it in. Sorry, these cameras keep going in and out of focus, and I just don't know why. Focus. So we're going to take, 200 ohm resistors, and basically we're going to send both audio signals to these 100, let's see, we're going to send the audio signals into these resistors. Oh, and I just mixed 2 of them together, so I don't know which one's which. I'm just going to grab a fresh one. Okay. So basically all that's going to happen is that the audio signal is going to go, so each audio out is going to 100 ohm resistor, and they're going to meet at the same rail, and then that rail is going to be our output rail, which then actually these two audio things can, audio outs can be on the same rail. And basically, yeah, we're just going to create two little plugs for our two outputs to go to. And so the way I'm going to try to build this is just create, let's think about this for a second. Well, maybe it's better if we go like, yeah, so I'm going to need audio, so audio 1 can go there, audio 2. Okay, so I'm going to give one of these resistors a little snip. Okay, looking good. Okay. This is going to be our little mixing section over here. Oops. Okay. Plug this back in a bit. Okay. And then we're going to take this other resistor, and it's just going to go another rail over. So I'm going to make this one have legs that are just a bit longer than the last one I cut. Maybe it's too long, but okay. So this one is now go over here. The important thing to remember is that basically there's two, on one side the inputs are unique, and on the other side they're actually on the same rail, the same row. So it's kind of tiny, so if you need your glasses or something. Great. Cool. So now we basically have a super basic mixer, which is kind of cool to think about. That a mixing board is really just, adding together different voltages. So now I'm going to plug in my audio outputs into that row where both resistors are on the same row, and that will send that same signal to both outputs of my audio jack. Yeah, it's a little tricky sometimes to get it in there, but hold on. Bear with me. Pop it in there, and then you can go there. Okay, so cool. That works. Everyone's blinking. Okay, so now the only thing left is to have our two audio outputs go in to those two rows over here that have their own 100 kilo ohm resistors on it. So just for the sake of consistency, I've used yellow for audio output, so I'm gonna grab some more yellow cable here. You can check it out, okay? And it's gonna be a little bit longer, so we gotta go from here. Let's just kind of eyeball it out. We'll have this one go closer, so maybe like this long. Okay. And we're going to crimp accidentally cut it. Let's just take that off. Okay. And we're gonna crimp. Sometimes it's easier just to bite it and go. Okay. So now we're gonna send this audio out over here to our. Let me try to see if I can get it under the ground. Maybe. Nah. You're over there, so. Plug in there. Oops. I might need a little bit more crimp on this. Okay. Okay. So that's going to be our... Okay. So that's one output for our oscillator. And now, just for fun... Okay. So it looks like our second oscillator is making sound. Okay, great. So that means it seems like our mixer is working. I haven't mixed in the second one yet, so you can't hear it if I toggle the potentiometer. So I'm just going to lower the volume for a second, and I'm going to grab that other wire that I have, and oh, we need a really tiny one actually. So I'm just going to grab this here and here. Crimp it. When it's really tiny, I find just biting the other end and pulling is actually pretty effective. Just try not to swallow any wire. Okay, great. So this is going to take a tiny connection because it's just going from there. Let's try to bend it a bit. This in there. If you have any sort of like tweezery, pliery thing, it could be helpful. I just ordered some because it can be a little tricky getting stuff into a small space, but if you just really focus, you can do it. Okay, now that's going to go in there. That's going to go into our first oscillator's output. And there, and I'm blocking the aerial view. Okay, great. So if you look there, if you can see closely, let's see if I can zoom in a bit. Yeah, it looks good. You can zoom in a bit up here. Okay, it's a little out of focus. Okay. So now we have, and maybe the yellow is a hard color to see, but our second oscillator output's going into our little dual resistor mixer. And if I turn on the speaker, I now have two oscillator signals mixing together. So you can hear our blue one, now our green one. I can tune them together. And there you go. Now we have two oscillators mixed together in what's essentially a very tiny but pretty mighty synthesizer. I really like the sound of this, the sawtooth waves that it outputs. They're very rich, really like fat and little bit more hardy than digital audio. So you can just kind of play around with it. Tune it to a fifth. Maybe. It's a little touchy. Or a third. There we go. Okay.
Here's how.
Yeah. Okay, so now we have a fifth. So there is a super simple circuit to just start making sound using basic electrical components. No integrated chips, nothing, no Arduino, nothing digital. It's just voltage going through a circuit, going out an audio jack, making a speaker cone wiggle. And for me, I think that's pretty cool. So, yeah. Just something to notice, these oscillators, they have different high notes. So if I open them up all the way, it sounds like the blue one can go a little higher than the green one. I'm not totally sure why that is. Oh, I'm sorry, the green one is higher than the blue one. Oh, that's right in. So when you tune them right next to each other, you can get like some nice phasing, because it's pretty hard to get them perfectly in tune. But I think it's a pretty cool sound. You can detune it a bit, get even more phasing. Put them both really low. And it's almost like percussion or something. So just to talk a little bit more about this, so the one that I initially made, I actually ended up remaking it because I was trying to get it to work and it wouldn't work. And so I thought maybe it was the breadboard, which, since I couldn't see anything else that was wrong with it, and so I just put it on a different breadboard. But I don't know if that was even the problem. I think it was the fact that the LED was just facing the wrong direction, and so the current couldn't flow properly. And so this kind of stuff happens all the time when you're working with components like this, and it can be a little bit of a letdown, right? You spend all this time putting together all these wires and doing all this stuff, and when you fire it up, nothing happens. This is, I think kind of a part of the learning process, and the key is to not let it get yourself discouraged when that does happen. You have to have a little faith in your ability to troubleshoot, which, we don't really like to troubleshoot things as much, so, but it's a really great thing to just stick with it, even when, it doesn't work, and, it's a little bit of a process. That's where your multimeter can also come in handy too, because you can check connections of things and see, like, well, is there even current going through it? What is going on inside of here? And so that helps you test some stuff. Other troubleshooting things, sometimes, an LED comes and it doesn't work. It happens. So pull out another breadboard and test your components by itself. Maybe your batteries don't have charge, so you have to, you can double check if your batteries have energy, and if your LED is working. So just a few ideas on troubleshooting, which obviously it's awesome if you can just plug and play after you put it together, but I think, that probably takes some time to develop more skill and intuition on, but at least in terms of, getting started, having some methods on how to troubleshoot can be really helpful so that you can just, get around to playing with some sound.